Muy bien, muy buenos días, muy buen día a todas a todos. Vamos a continuar con el curso, con la sesión de hoy. Hoy tenemos una sesión también estrella porque tenemos unos ponentes excepcionales. En primer lugar tenemos a Mathilde Marengo, es jefa de estudios del Institute for Advanced Architecture of Catalonia. Ella ha desarrollado toda una línea de investigación y de formación de análisis del fenómeno urbano. Entiende la arquitectura no como un hecho aislado de diseño, sino como una forma de enfrentarse a la problemática social, a cómo definir la ciudad, el entorno, a cómo relacionar personas, espacio y calidad de vida. Y este proyecto, esta visión de investigación, la potencia la desarrolla en el instituto, de la cual ella es directora académica y supervisora de tesis doctorales, con lo cual tenemos la suerte de contar con su presencia y nos va a explicar un poco este modelo innovador del cual ayer ya empezamos a hablar, de elementos de transversalidad a la hora de enfrentarnos a los fenómenos sociales. Mathilde.
Ok, gracias. Una pequeña corrección. Yo soy jefe de estudios, no directora académica.
Bueno, vale. Perdona.
Okay, so I'm going to talk in English. First of all, I'd like to thank you very much for the invitation. It's a huge pleasure for me to be here. I have to be honest, in the beginning I was a bit skeptical. I mean, I understood that it was about new educational models, but I was a bit skeptical as to what I might be able to bring to a forum around economics. But after yesterday's discussion, I am super intrigued and I was very excited. So thank you very much for inviting me here today. So I'm going to discuss education, so designing the future and building it in the present, which is how we work at IAAC, which is the Institute for Advanced Architecture of Catalonia. So IAAC, just to give you a little bit of background on the Institute, is the Research, Education, Digital Fabrication and Promotion Center, and we're located in Barcelona. In the background you can see one of our projects which is still standing. So we worked on these projects with a series of students. It's the Endesa Pavilion and it was built for the Smart City Expo in 2011. So this building has now moved on to a second life cycle. So it's now a chiringuito on the beach in Porto Olympic. It's been painted red because unfortunately in 2014 it was assaulted by some pyromaniacs. So we lost some solar panels, but we kept some, and so it's moved on to a second life. We are devoted to shaping the future habitat of our society and building it in the present. This is really important because we don't work with speculation as such. We use speculation as a design tool, but our interest is to speculate as close possible to the reality. It's probably useful for you to understand what advanced architecture is, to understand a little bit how we're working. So advanced architecture is, let's say, an architecture which is related to technology. So the founders of the Institute was founded just under 20 years ago, so it's a very young institute. And the founders at the time of the founding saw that there was a change in paradigm in the discipline of architecture. So architecture was no longer only related to physical space, but also became related to digital space. So advanced architecture is this architecture which relates to technology, working in both the physical and digital realms. The first thing that they did, which is quite nice, is they defined the discipline, and they did it in a very traditional fashion. So they developed the dictionary for advanced architecture, so defining city technology and society in the information age. And this project, I think, is quite interesting because already at the time, they connected a series of, let's say, people who were working in architecture, but in the same kind of fashion that they felt architecture was changing. And they invited them all to give their definition of the terms that are related to the discipline. Today, we have evolved, we've grown, and I just want to read a quote from our academic director, Areti Markopoulou, to explain a little bit where we're going now. So the information society brings a digital revolution dealing with collectivism, connectivity, and endless proximity. Can the machine think? Can the building think? Can they evolve? We started talking about the internet of cities, the internet of buildings. The innovative technologies and the information in the experience era are mutating the way we inhabit our environment. We are moving to a form of habitat in which architecture is no longer merely sheltering, but becomes evolutionary, technologically integrated, and even personalized by the users of the spaces. So to help you understand how we work, I think it's very useful to understand what kind of research environment we're working in, as these facilities or these tools that we have at our disposal allow us to develop the projects and work with the methodology that we're working with. In the background here, you can see some of the individual thesis projects from the students of our Master in Advanced Architecture. So we have from a desalination system to working with seagrass for new biocement materials, mycelium, which is a type of mushroom, looking at bioscaffolding processes, and much more. So we have our main campus, which is our building, has been our building for the last 10 or so years, is located in Poblenou in the 22 At district. It's an ex-industrial building, so it's very much a workshop space. So already when people walk into the building, they kind of understand that we're not here to sort of sit at a desk and write things, but we're really here to start materializing things. Of course, we have a series of tools that allow us to do that. So Fab Lab Barcelona is actually part of our institute. Fab Lab Barcelona was the first Fab Lab in Europe. For those of you who don't know what a Fab Lab is, it's a fabrication laboratory. I'll talk a little bit more about it in a couple of slides, but basically the idea is to give tools for digital fabrication to the general public to allow them to be able to make almost anything, let's say. So Fab Lab Barcelona is also the global coordinator of the Fab Academy program, which I'll also talk about a little bit later on in the presentation. And a Fab Lab basically gives you a series of tools. So this is a laser cutter, so you can engrave or cut in 2D. We have 3D printers. We have CNC milling machines. And we have also electronics labs and other spaces. We recently also acquired another building, which is dedicated entirely to our master's students, which is called the IAAC Atelier. And so this gives a little bit more space for the students to start working. And in the IAAC Atelier, we also have a special lab for the master students, which includes, of course, the classic digital fabrication tools that I was talking about before, so 3D printers, laser cutters, milling machines, robots. We have an electronics lab, and we also have a bio or matter lab. And finally, we have another campus, which is located just 20 minutes from Barcelona, which is the Vall d'Aura Labs. The Vall d'Aura Labs is a self-sufficient research center. It's based in the Collserola Park, and there we have 140 hectares of forest, in which we allow the students to sort of materialize and test on long-term their design. So obviously when we're working with architecture and we're talking about testing, it's not something that you can test over a few days because architecture is designed to stay a little longer than that. And so we do have the possibility to work in long-term projects there. So this, for example, is, this standing on top is me for scale. This is a Catalan vault that we parametrically designed and built with the students in the Vall d'Aura Labs. We also have a series of different laboratories located at the Vall d'Aura campus. So we have an energy lab, which is dedicated to developing, let's say, innovative energy management or energy production solutions. So these include projects, for example, this is a wind energy machine that came out of one of our master programs. We have a green Fab Lab. So it's another Fab Lab, which is part of the Global Fab Lab network, which is oriented to developing nature-based solutions, so working with natural processes, understanding different kinds of material cycles than what we would have necessarily in the city. And we also have a food lab, which goes from more traditional agricultural production to innovative food production, so for example, testing out aquaponics or hydroponic systems, but also integrating robotics and sensing into food production processes to be able to collect information and data and make our food production processes more efficient. So as I was saying before, I was going to, excuse me, I'd like to explain a little bit what the Fab Lab mission is. And so the idea of Fab Labs came out of Professor Neil Gershenfield from the MIT. So in 1998, Neil Gershenfield set up a course called How to Make Almost Anything. And his idea was to understand how we can empower people to engage with technologies, to be able to start sharing information, to be able to start producing things locally, and not only manually but also digitally, so managing the efficiency and precision of these. And Fab Labs, the Fab Labs are part of a global network. So this is a print screen. It's actually a little bit old, I think. So at the time of the print screen, we had 1,218 Fab Labs. So the Fab Lab network started in 2002. But these numbers grow exponentially. So this is the log number, but this is the actual real growth of the number of Fab Labs globally. So we see that there's an exponential growth, which is great because this starts to engage with the people and empowers people to actually start making real change in their cities. Speaking of which, I would say our central agenda of IAAC is working towards self-sufficiency. And so our interest is to empower people to make real change in, for, with a performative habitat that evolves towards a positive future. This is actually a picture of our team. Recently, we have an IAAC day every year where we go up to Val d'Aura and do a series of team building exercises, discuss a little bit about how we're working together and what we're aiming for. I have to say, it's very nice to be located in Barcelona. So I've worked in other cities around the world. Barcelona is a city that in 2014 won the first iCapital Award that was ever given by the European Commission. And it won this award for introducing the use of new technologies to bring its citizens closer to the city. So in this sense, the context of Barcelona, when we consider the city as a laboratory, is very engaging, it's very motivating. And so I have to say that it's a very pleasant place to be working. So what I want to talk about is 5 points that I think are crucial for our educational development. The first is systemic design, and I think they're quite similar to some of the points that Tim was discussing yesterday. So systemic design, so looking at multidisciplinarity, multiscalarity, and developing design through research. Learning by doing, which we do through the development of real case studies, obviously with real-time information, using the city as a laboratory, but also working with the industry, so engaging with the people who will be working with these processes after. Sharing information, definitely. So from distributed educational formats to having globally connected cities and locally productive cities and multi-directional learning, So this has a lot to do with what Tim was talking about yesterday, connecting up. Adaptability. So this is another very important point. So we're constantly evolving and we're in a dynamic environment. And the last is the horizontal structure. So we don't have hierarchical development in our educational programs, but we rather consider ourselves all researchers, and we are researching together with the students. So we're all constantly learning. And this is really important also because of the fact that we work with new technologies. Technology evolves at a very, very fast pace. And so to be able to constantly engage with that and not be left behind, we need to constantly be updating our processes. So with systemic design, I'm going to show you a few projects that I think help illustrate a little bit what I'm talking about. And they do, to some extent, touch on the topic of economics. So these projects are developed through our educational programs. One thing I didn't mention before, but I think is quite important, is that for us, architecture is multiscalar and multidisciplinary. So we design from bits to geographies, and I say bits talking about a digital realm and geographies talking about a physical realm. But we also work very closely with people who are specialized in other disciplines to be able to develop our projects, make them real, and push them the furthest forward possible. So on-site robotics came actually out of an initial research that we were doing a few years ago, which was developed in the Open Thesis Fabrication program, which is an applied research program which runs for 6 months. In which the researchers look at materializing specific solutions for the built environment. And over the past, I think, well, since 2012, we've been working on an agenda of 3D printing in the architectural scale. So 3D printing becomes very interesting in the architectural scale because you can optimize and customize the form of what you're developing. It has a series of setbacks or difficulties, challenges that are associated to taking 3D printing to the architectural scale. So one of them is what machine are you using, because usually a 3D printer needs to be bigger than what you're actually printing. And obviously when you're printing houses, that's a little complicated. So we did develop a project called Mini Builders, which was working with 3 small-scale robots that work together in swarm technology to be able to print structures that were much bigger than they were. And the other very big question about 3D printing in architecture is the material that you choose to use. So most of the 3D printing done in architecture either works with plastics or 2-part polymers. So materials that one could also question whether they make sense to be introduced into the architectural realm. So from that initial problem, let's say, or initial situation, we started working towards the possibility of 3D printing with natural materials. So the first iteration of the project was developed in Pylos. Pylos means dirt in Greek, I believe, yes. And so we were looking at the possibility of using natural materials that one could collect on site to be able to create a material that we could 3D print with, which would be 100% natural. So potentially, if you don't like your house, you can just bash it down and print it again, or you can bash it down and just give it back to the environment. So from then, in 2017, we developed a project called On-Site Robotics, in which we teamed up with Technalia. Technalia is an innovative engineering company, and they gave us the possibility to use one of the technologies that they're developing called a cable robot. And with our material research, the technology of Technalia, and also other layers of technology developed with one of our partners, Numena, we were able to generate a large-scale 3D print within the construction fair called Construat, so over a period of 2-3 weeks, I think. So I'm going to play a small video, if it plays. No, it won't play. Hold on.
With the project of on-site robotics, we want to rethink the process of construction from the very first moment of the extraction of the material to the very last moment of construction, performance of the building, and of course the design of it.
By constructing with 3D printing, we can introduce new materials. By new material, we believe that sustainable materials such as earth are something that could be reintroduced into architecture. The actual design that we present here are actually showing how a wall could be much more intelligent in the way we distribute the matter and how it can perform as a really good insulator at the same time as a pattern that could self-shade itself.
The role of our drones in the project of on-site robotics is about monitoring the fabrication process, providing data related to the quality of the clay and related to the hardening of the material in order to understand how much we can grow during time without collapsing the structure.
Gojiro is based on the cable robotics technology. It is very suitable to optimize automated operation in large workspaces. The technology is very transversal, so it's very versatile, so can be used in different sectors for performing different
So this project touches on a series of topics which I think are very important at the moment in the architectural industry, and that are related to also economics and other things. So for example, the construction industry is responsible, I believe, for 70% of CO2 emissions globally. So how can this kind of working with natural materials that can be found directly on sites, working with a technology that can allow you to build directly on site, how can this start changing the processes and reducing, let's say, the footprint, but also the costs of construction itself, because the material in theory doesn't have a cost. And so this becomes quite interesting. It also becomes interesting during the lifespan of the building because, as Alex mentioned in the video, the material itself embeds energy. It has the possibility to perform. So it's a passive performative system. So in that sense, how much electricity you will need to cool your building obviously reduces. So the costs during the lifetime of the building itself are greatly reduced. And then finally, when you don't like your building or you don't need your building anymore, then you can potentially just bash it down and give it back to the environment. So these are quite interesting things quite interesting, very important things with respect to the construction industry. These are topics that we're engaging with daily. And of course, one of the important things that I want to say, I'll go back to the presentation. One of the important things I want to say about this is that, of course, we can't do it by ourselves. So yesterday we had a lot of discussion about multidisciplinarity and engaging with different people. So of course, without Technalia, we couldn't have done it because they have the technology, they have the knowledge associated to the technology. But without us, they couldn't have done it because we have the material and the knowledge associated to 3D printing. Without Numena, we wouldn't have been able to work with the drone. So also the constant feedback loops and machine learning in the process of actually producing the building. And Lirim, who provided the actual drones. So this way of working with education is very important because we don't know everything, and that's okay. But what we do need to know is how we can start working together with people to be able to get collectively where we'd like to go. So this is very important for us in IAAC, and we work with all our projects in this sense. I'd like to show another project which I think is quite interesting from this perspective. It's a project that was also developed in the Open Thesis Fabrication Program. This project was developed in 2014 and it's called Moss Voltaics. So it works on living systems that are capable of generating electrical energy. So it works on a biophotovoltaic process. So basically, a plant does photosynthesis in any case. And when it does this photosynthesis, what a plant does is creates a series of bacteria in its roots. So this bacteria, with the insertion of an anode, can be collected and transformed with a cathode into electrical energy. So obviously this is a huge, this is a very important thing, because if we start thinking about all the green spaces in our city that could potentially become productive in terms of energy, electrical energy, then this changes greatly, let's say, how we could produce energy and how we imagine our spaces in the city. So this project was developed in collaboration with Paolo Bombelli, who is a biologist from the University of Cambridge, and Tony Cumeia, who is a ceramics artist. He has a ceramic company called Cumeia Ceramica. They're probably most well known in Barcelona for the tiles on the Mercat de Santa Caterina roof. So the colored tiles were developed by Tony. He's a lovely person and he works a lot with us because, as you can see, we're working with natural materials quite a bit. And here, once again, I have a little video that I want to show you. So this project, we developed it up in our Valdaura labs. So we collected the moss directly. We collected the moss directly from Valdaura. So it's locally sourced material. This is a little bit to explain the process that I was explaining before, the biophotovoltaic process. And again, it's interesting to be able to take advantage of a process that in any case plants do. So we're not asking the plant to do something that it wouldn't normally do. We're just taking advantage of it. Of course, this process we wouldn't have known or have been able to delve so deeply into it without the help of Paolo. I mean, we needed a biologist. So this is up in the Valdara Labs, so preparing the anode. This is Thor, our dog. He was an integral part of the project. So as I was saying before, that anode preparation took 1 month. So it's not something that we can do overnight. Architecture does have a different time for development. And what we decided to do in this project was develop a vertical brick system. So looking at the possibility of creating, let's say, green walls that could produce energy. So this was, the shapes of the bricks were parametrically optimized to have the best possible situation for the moss inside the brick. So shading and sun is very important. And of course, an energy production system that also has a positive impact on the environment is top. So this is the fabrication process that we developed at IAAC. So we used the CNC mill to mill some plaster casts to be able to do slip casting to create the bricks. So testing is a very important part of what we do. So obviously we didn't design and develop the final brick straight away. So what we did was we developed a smaller scale prototype of the bricks themselves to test and see if the design could or had to be optimized to some extent. So in this process, obviously Tony was very important because he taught us about slip casting, so maybe more traditional technologies, but technologies that are necessary to be able to develop the projects that we're aiming to do. So these are the small scale tests. And we moved on to the large scale design. So these bricks can be set up in parallel or in series. And the design of the brick itself is what allows the connection between the bricks. So once again, milling. We also learnt other things from this experience. So, for example, it was the first time that we milled plaster, and milling plaster is disastrous for the milling machine because it gets stuck in the nozzle. So it's a learning experience all the way around. And then these were slip casted and sent to Kumeya. So he did the finishing of the bricks for us. These are the elements that allow the electrical connections between the different bricks. So we set the moss that had been prepared in Valdara in the meantime into the bricks. And hook them up. and they make energy. Of course you can. We set the target at making a vertical system. We also wanted to work with a modular system. So it's a 6-month course. So the development of a green roof required obviously a series of important factors like water drainage and things like that, which make the project slightly more complex, so they need a longer span of time. In any case, this project hasn't stopped here. This is another thing I want to talk about now. So we never stop. Oh, project done. Goodbye, thank you. Yes, we are currently working on it, so hold your horses. No, so obviously this couldn't be done without Tony. So Tony is a fundamental part of our institute, I think, actually, now that I would consider it. And of course, without Paulo, who continues to collaborate with us in the development of these nature-based solution projects. So Paulo is a biologist, Tony is a ceramic artist, and then we had our internal IAAC team and students working together. So as Tim was asking, can we do green roofs? Well, we're doing more. So since then, we've set up a European project proposal, which we won. So it should start actually this month. And it's called Urbinat. So it's looking at developing nature-based solutions in urban contexts. And we're working with a very large network and a series of cities in which we will actually actuate these projects and test them. So we'll be looking at productive systems from the perspective of energy, but also productive systems from the perspective of food and obviously their technological integration. So we are responsible for the design and prototyping of these elements that will be then actuated into a series of different cities. So that's the next step, the real scale testing. So let's say up until now we had a readiness level of 5 or 6, so now we're taking the next step. And again, these European projects then are reintegrated into the courses, so we have the possibility to work with the students in real cases, which is obviously much more engaging from their perspective rather than working with hypothetical or speculative scenarios. So the second point I wanted to talk about,
we have
10 minutes, oh my God.
10, 15 minutes, yeah.
I'm like at point number 2. Okay, I'll try and be really fast. So learning by doing, working with real case studies, real-time information, using the city as a laboratory, and working with the industry. So I had 3 projects, maybe, I guess I put this one for Tim. But we can skip it and I can show Tim later. This is Fusta Robotica. This was actually a really interesting experience. So we worked together with a series of wood industries from Catalonia. So Catalan wood isn't usually used for construction because it's a very green wood, so it has a lot of distortion. It's a very flimsy wood, so it's usually used to make pallets. And we were interested in understanding if through digital fabrication processes we could optimize this to be able to use this Catalan wood in the construction process. And this video won't play, so it's not a problem. But basically, I think the takeouts from this project, so basically we developed a design that would take advantage of the actual wood's, let's say, defects or the reasons it's not being applied in the construction industry. So the distortion through the design of this, we take advantage of the distortion to consolidate the structure. We also use robotic fabrication processes, so we perfectly customize each of these pieces is a different length. So it was really interesting when we were talking with the industry because they came and worked with the students towards the development of this project. And as soon as we said that each piece was a different length, they were like, no way. You're joking, like this is not possible, this is not going to happen. And we were like, well, hold on, let's see how we can make this work. So it was, I think, a very interesting learning experience both for them and for us. So we were engaging with people who had a lot of knowledge on the material itself, and we had the opportunity to, in some sense, share our knowledge on potential fabrication processes with them. And again, the importance of working together with the industry, because also the industry needs to evolve, no? So this is their opportunity when they engage with educational platforms to be able to evolve and change. So we were sponsored by Serradora Boix, and we worked with a series of Catalan wood companies in collaboration with our team at IAAC. So we had robotic fabrication experts and a group of students who we consider researchers. This project, the next project that I want to talk about is a project that was developed in our Master in City and Technology, and looks at designing engaging with citizens in urban design. Just quickly for you, this is probably the project I have the most slides on, so I'll try and be very fast. So 70% of our population lives in urban areas, and public space is the heart of the city. So what happens to our public space? How can we start making this public space active, let's say? So the current trends are towards pedestrianization of public space. This is Times Square in New York. But beyond pedestrianizing our space, how can we start making the space or allowing the space to respond to our ever-changing needs? So maybe the needs of people changed slowly over the past decades, but now the pace of change is getting faster and faster. So the city of Barcelona developed a project called the Superblocks, where the idea was to work with a 3x3 grid and reduce the traffic within the grid. It would reduce the traffic of 21%, and it would free up 60% of the space available. So for those of you who aren't from Barcelona, Barcelona has a very big problem of air pollution, and a lot of it is due to traffic. It also has a large problem of noise pollution, and same thing, it's due to traffic. So reducing 20% of the traffic, which occupies 60% of the roads, we have the possibility to give space back to citizens. And I think this number of 20% versus the 60% of the space that they occupy is really shocking, you know? So a great majority of cars are just parked. I can't remember who I was talking to the other day, and he said, you know, just imagine if you were an alien and you came to outer space and, you know, you saw cars, and, you know, you would have thought, well, what are these people doing? You know, like, it seems we have cars just to park them. So that was quite interesting. In any case, for those of you who don't know, this is how Barcelona functions currently, and this is the model of the superblock. So reducing the inner traffic and freeing up space to have more sustainable mobility, a revitalization of public space, promotion of biodiversity, and another series of things. From my perspective, this makes a lot of sense, being an urbanist. So the city of Barcelona decided to actuate a super block in the Poblenou area. IAAC is located just down here, so it's right next to us. But the reception of the super block itself was very negative. So from my perspective as an urbanist, I see these points, these ideas, these numbers, and I think, wow, that's a genius idea. Yet, obviously, the people who were living there don't necessarily feel the same way because they don't have the same knowledge that I have. And so they weren't very happy about it, probably because one of the things that they are interested in is being able to go home and park their car under their house. And to the point where there was also the questioning of whether these super manzanas, these super blocks, would actually help diminish the contamination in the city. I understand also the possibly negative reception because this is a picture of the first phase of the development of the super blocks. So basically they just shut off the roads. So there was no change in the space itself. So what we did was we developed a gaming interface to invite the citizens to be able to play or design their superblock. The gaming interface is a very simple platform, and the idea of the project was to engage with citizens who don't necessarily have the tools that we as architects or urban planners have to be able to design their city. So the gaming interface is like a new language that both the citizens and the designers or the people who are working in planning this area speak and can understand. Obviously, this was a very interesting experience, so we did an event in the Superblock, and we asked a series of people to play the game, and we collected the data and information from this game to be able to understand how people engaged with the area, what they were hoping to have. So we had different categories of information on this game, and how they expected or desired the area to be designed. It's very important that this game is not only a design tool, but it's also a learning tool. So every module that you have that you can select and insert in the game is set with a series of counters, and these counters give you a score. So the idea is to have higher points and the most balance possible. So not only are the people designing their space, but they also have the opportunity to learn what it means to actually design this space. So what are the impacts in terms of economy, productivity, ecology, accessibility, or social and cultural activation? And so they too start learning through this process and need to play the game more than once to be able to speculate less and consciously or make informed decisions more. On top of which, it can also be tools for designers to do exactly the same thing. So I have a weeny video. Very, very fast. So this is a little video of the actual happening that we did. Explains a little bit about the Superblock. So as you can see, the area was basically just cut off to cars. It was very interesting because the city of Barcelona did invite all the architecture schools to come and participate and take an active role within the Superblock. So from that perspective, I think the city is engaging with education as a way to reinvent the city itself. So this is how the game works. So you can click on different modules that have been set up, learn about the modules themselves, and then drag and drop the modules into the places where you would like these to be. So we obviously collect information about what people wanted, and this information then becomes data which can be used for the people who will actually go and design the city to engage with. So this is a data map. Since then, we've developed the Superbarrio project in also Genova in Italy and also in Favara in Italy in 2 different scenarios. So modeling the spaces in these scenarios and giving the citizens the opportunity also there to engage with the production. So multiplication is obviously important in these projects. And it's obviously a great opportunity for the citizens to be able to engage with design processes. Again, of course, we couldn't have done that without a series of different partners. So we had a European-funded project which gave us backing for this. The Poblenou Urban District was involved in the Superblock project, as well as the Colectivo Superia Poblenou. And then we had a diverse team from IAAC, including the students of the Master in City and Technology. Another project which I think is very important and which engages with changing the industry is the Interchain Network. So it's a Marie Curie funded project, and the network is a shared research training environment that looks at developing the digital chain. So enabling the industry to advance through the research of early stage researchers, which are located in 6 different universities around Europe. Of course, once again, this isn't possible without the help of the industry. So each researcher engages with at least 2 industry partners with which they go and work. So they're not only located in an academic environment, but they integrate into the industrial environment to be able to fully understand how and if the application of their research makes sense within the industrial framework. So this is, I think, a very interesting PhD program, and we're running it with a series of other universities around Europe. It's also very important in terms of sharing knowledge. So it's a Marie Curie training network. So this means that researchers who come from the outside come to Barcelona and learn within Barcelona, exchanging with other people, which again is another very important factor for education, the fact of sharing knowledge. Sharing information, in fact. So we have a project called Fab City, which I think is interesting for economists. Fab City came out of the Fab Lab network. It was developed by our Fab Lab in Barcelona, which then evolved into the Fab City Research Lab. So in 2014, we hosted the Fab 10 meetup, which is a global Fab Lab network meetup. And we proposed a topic that went from Fab Labs to Fab Cities. So the idea is to generate locally productive but globally connected cities. So basically, we changed the production model from a linear industrial model where the elements are extracted, transported, produced, transported, consumed, and inevitably become waste. Of course, with all of this transportation, we have an important impact, to rather, which is a product in, trash out model, to a data in, data out model. So exchanging data globally, but creating circular fabrication processes locally. So it goes from a linear model to a circular model. Barcelona was the first city to accept this challenge, and it accepted it in 2014 at the Fab 10 conference, and it decided to become the first Fab City. So one of the things, obviously, that's very important is to start developing Fab Labs. So two of these Fab Labs, Fab Lab Barcelona and Green Fab Lab, are ours. The one with the little red toggle are Fab Labs that have been set up by the Ayuntamiento, by the City Council of Barcelona. This is just a little image of how a Fab City prototype would work, which we are developing in Poblenou, so engaging with all the, let's say, community centres, but also the fabrication centres, but also food and energy and material centres within our neighbourhood. And so that's one of the stages, so from the city stage to the neighborhood stage, but also to the global stage. So right now we have a series of cities or regions that have pledged, and this year we'll be having the Fab City Summit in Fab 16, I believe it is this year. Oh no, Fab 14. Fab 14, which will be hosted in Paris, which is this year's Fab Lab Global Meetup. So just two small examples on distributed education, so sharing knowledge globally but producing locally. One is Fab Academy, which is the program that I was discussing before. So Fab Academy is a program that is based within the Fab Lab network. And the idea is it's a 6-month program that allows people to engage with the Fab Labs and learn all the tools that they need to be able to produce almost anything, anywhere. This program happens globally, so it happens within all the Fab Labs around the, well, not all of the Fab Labs, but a lot of the Fab Labs around the world. Fab Lab Barcelona is the Fab Lab that coordinates the program, and this is Neil Gershenfield, the man who the program came out of, and they all connect once a week and discuss these elements. So again, sharing knowledge, globally connected but producing locally. We also have another school which is for undergraduates, which is called the IAAC Global Summer School, and it's powered by our alumni network. So we have alumni coming from all over the world, and so they often, well, a good part of them go back to their country after they've finished studying in IAAC, and they want to continue engaging with the process. So every year we have a global agenda which is developed then into local solutions. This year we have this many nodes, 14 nodes, and they're all over the world, and they are powered by our alumni network. So I think that's really important that we also continue to engage with our alumni. This year's topic is digitize, and you can find more on there. Last 2 points very quickly. Adaptability. So one thing that I do want to say, and I'll say it with the example of our Master in City and Technology, these are the professors that teach in our Master in City and Technology. It's a new master program, and it's important that I say 2017-18 because every year we update our programs. So every year we could potentially engage with new faculty or new programs that have changed. New programs, when I say programs, I mean new technologies that have evolved or have come onto the market recently. So 2017-18, this is our faculty. These are the people that actually work for IAAC. So most of our faculty is coming from out of IAAC to teach in IAAC, again, sharing knowledge. These are the different disciplines that they work in. So some of us are urbanists, some of us are architects. So these two colors are architect and urbanist. And the others are engineers, communication designers, economists, sociologists, journalists. So we do have a very diverse panorama of people teaching in our master programs. Not only that, but they also come from a series of different companies that we collaborate with directly inside the program to be able to actuate real solutions. So we are interested in working with our students in real cases, not in speculative cases. So to be able to do that, we need to engage with the industry. And just last point, so we have a very horizontal structure. As I was saying before, we're all researchers and we're all learning together. So this is a picture of one of our final presentations. And just to give you an idea, we have students, alumni, scientists. We even have someone's mum here. We have Fab Lab experts. And we're all standing in different rows, but together. So there is no hierarchy in our educational system. And I think for us, that's very important. The knowledge that we are all learning and that we all want to continue to learn and learn together. So our IAAC people are an amazing bunch of alumni that are all very talented, coming from 70 different countries around the world. This is a map of a couple of years ago of our alumni network, but also our team. So this is not the whole team, of course, but we come from 35 different countries around the world, and we are a multidisciplinary team of very motivated people who all believe, I think, very strongly in the project, which is IAAC. And with that, thank you. I'm sorry I took so long.
No, thank you very much. Un aplauso.